Good morning, everybody. So as we look to the future, part of the work that we've been doing, as I mentioned yesterday, is part of looking at the viability of CMA, viability of MD, is really trying to get some insight in terms of what is happening out there in the financial services world, the health world, the political world. New BC leader in Ontario, that should be interesting to see how that happens. And so as we look forward, there are so many things happening, and you'll hear lots of words like disruption, exponential change. And when we look at those themes, I mean, we couldn't be in a more exciting area other than healthcare. I mean, it's unbelievable what's happening out there. And I know I've had the opportunity, and I know some of you have as well, to participate in conferences, not only in Canada, but throughout the world, as it relates to some of this exponential change that's happening. And as we started to explore some of these areas, Dr. Brody and I had the privilege to attend many Singularity University events in New York, in California. Exponential Medicine is an annual event of which Philip is very much attached to. And one of the things that we would come away from is that we'd just be totally amazed about what's happening. And you're going to hear about some of those things this morning from Philip. And as we look at those things, there was all kinds of new words and terminology coming out. And I mentioned a little bit about this yesterday, in terms of blockchain. And blockchain is going to affect not only financial services, it's going to affect healthcare. And these are just new concepts, and it's difficult sometimes to grasp those concepts. And Dr. Brody and I have been reading over in these meetings and conversations, going, "What the heck is that?" And then we start Googling and talking to people, and we go, "Wow, we're onto something. Something's going to be happening here." And it's challenging because I'll reflect on a conversation I had yesterday evening. I've been calling back physicians who are calling into MSC, calling their advisors, and who are really worried about their future based on the fact that we sold MD. And so I'm taking every opportunity I can, so is Dr. Brody and the board members, to call physicians directly that are concerned. And this one female physician, 68-year-old female physician in Brunswick I talked to last night, she said that she was fully invested in MD. She had 8 of her family members invested in MD. And so I started to talk to her about the process that I explained to you yesterday. And so I could tell that it wasn't really working. And she was asking me, "Can you please back up, Mr. Smith? Can you talk about what's this blockchain? Blockchain? How do you spell that?" And so she was trying to catch up. And I said, I said there was a great article yesterday in the Medical Post that Dr. Brody was interviewed. It explained some of the reasons behind the sale and where we're going. And she was like, "I don't have time to read the Medical Post. I see 40 patients a day, and here I am trying to gear up for my retirement, and you just pulled the rug from under my feet." And so this is kind of the attitude that we're having to deal with and talk to. Be very patient. We were talking this morning at breakfast this morning. Stephen's son is working for Elections Canada. Is that right? Elections Canada, and getting these random calls from people looking for Elections Ontario, and people calling in for their visas for the government. And you have to have such a calm nature when you're talking to people, because they are anxious. This is about their personal well-being. And so that's one of the things that I appreciate so much about the CMA, is that we really have that culture and that attitude in terms of helping people and understanding and listening. I think that's the biggest thing, is that I think we're very good at listening. And so when we look at the future, I think it's good to be frightened a little bit, because it keeps us on edge to say, okay, well, what's next? We need to be agile. We need to be thinking about things. How many times have you heard me say status quo is not an option? And that, we're going to be going through this change. We need to adapt and adjust based on what's happening in our world, whether it's personally, whether it's professionally. There's so many areas that this affects. So I'm super excited now that Philip's finished breakfast that I can introduce him. How's that for Philip? So Philip Edgecombe got introduced to me indirectly through Dr. Brian Brody. Dr. Brody had met Philip at a Singularity University event. And when you look at his profile and you see what he's accomplished, it's okay to say, oh my God, what did I do this morning? I just got up and made eggs. Philip has accomplished so much in his early in his career, and he's going to talk a little bit about some of his experiences and where the future is going, and some of the things that are going to impact us. I'm just going to highlight a few things. Philip is an award recipient of the Canadian Medical Hall of Fame, so he's a recent recipient of that. He's also a recipient of what's called an X Prize. Singularity University has this competition that they put on in terms of solving big, audacious issues. And Philip and his team won 25 million US dollars to eradicate Alzheimer's. So no small feat in terms of what that accomplishes. I also got a little bit of insight on Philip that he doesn't know. He spent some time up north with the physician Dr. Alex Poole, who is the CEO slash president of Yukon Medical Association. I spent some time with Alex this week, and it just so happens he's a surgeon up there, and Philip was interested in surgery because he's done so much already. And he spent a week with Alex up in the Yukon, and he said it was such an engaging experience working with Philip and seeing him interact with patients. And he said he learned a lot in that week. And he said if everybody had the opportunity to engage with Philip in that kind of environment, he said he thinks that Canadian physicians would be in a better place. So I thought that was a very high accolade coming from Dr. Alex Poole, general surgeon from the Yukon. He says to say hi. And so without further ado, I'm going to introduce you to Dr. Philip Edgecombe.
So there I was, clinging to the side of a cliff, my arms getting tired, my hands a little bit cut off, and I was starting to wonder if I was going to be able to make it to the top. And so you might be asking, what was I doing on this cliff? Well, the story begins back in Vancouver, where I grew up, and I've always wanted to climb the West Lion Mountain, which overlooks the Vancouver Harbor. And one day, my friends and I got together, and we imagined what the view would be like if we could make it to the top, and we set out on the adventure. Now, sure enough, the path was difficult, and we had to persevere through some challenges. But when we made it to the top of the West Lion Mountain, the view was incredible. On one side, we could see the harbors playing in the Vancouver Harbor below, and on the other side, these untouched islands and mountains as far as the eye could see. And so none of us know what the future of healthcare looks like. But if we could come together and define a vision like this, a vision where we know what the future could be like, it will make the path we need to take and the challenges that we need to overcome that much clearer. And so that's what I want us to do today, is come together and develop that vision. Now, it's not going to be easy. There's definitely going to be challenges along the way in healthcare, but I'm excited about the future. I think there's a future where doctors are truly fulfilled in their work, where they have time to spend with patients and on the matters that they really care about, and also a future where patients feel truly empowered, they feel understood, and their healthcare is personalized to who they are. There will be challenges, but I think that's where the CMA come in. As people that get to shape the narrative and the view of healthcare, the CMA needs to develop that clear vision, that optimistic vision of what the future of healthcare looks like. And with that vision, all of the things that the CMA has laid out in the strategic plan become much more clear and accessible. With a clear vision, it's easier to engage in courageous, influential, and collaborative dialogue. It's easier to unite and inspire physicians on health issues and causes that matter. And I think it's also about you. If you can connect with that vision of healthcare and connect back to how the CMA is going to get there, then it makes the work that you're doing so much more fulfilling. I mean, I can think of several projects that I've been on where sometimes the day-to-day hasn't been rewarding. Sometimes it's been frustrating because I haven't felt like I've been making progress. I haven't felt like I've been appreciated. But as long as I connected back to the vision of what I was doing, it made the work worthwhile. And as I look at the mission and the vision of the CMA, I think you guys have it pretty good. I mean, your job is to come to work and focus on empowering and caring for patients. And I think that's really exciting. So I've got skin in the game, so to speak. I'm hoping to be practicing medicine for the next 100 years. And so my commitment to all of you is to just pour my heart into today's workshop so that together we can help CMA get the next few years right. And I'm going to be making some provocative predictions about the future of healthcare. And my hope is that at the end of today, you have a better sense about the underlying forces that are shaping healthcare, a renewed sense of urgency to act, as well as a playbook, both personally and as an organization, for going forward. So I certainly don't have all of the answers. I'm at the beginning of my career. And today, I've set up the presentation and the workshops so that we can make the most of the brain power and the experience that is in this room. And so to that end, I'd like all of you to think about the future of healthcare. Just sit with it for a little bit. The future of healthcare. And I'd like some of you to share what comes to mind, your feelings or what a word that encaptures your feelings and your vision for what the future of healthcare could be like. So who's going to kick us off? Borderless.
No wait times.
No wait times.
Opportunity.
Opportunity. Efficient. Equitable. Integrated. Customizable.
Self-directed.
Self-directed. Relationships. Well, excellent. Those are some great ideas, and I'm really fired up for today. I mean, we're going to be dealing with some complex issues and this big potential of what we could make out of healthcare. And so part of today, the theme of today is innovation. And so I'm going to break my talk up into 3 parts. First, I'm going to talk about innovation, technological innovation in healthcare and what that means. Then I'm going to talk about a new model of innovation, harnessing the crowd for the purpose of innovation, and wrap up by talking about how you can focus on developing your own innovation mindset. And of course, while we're talking about big ideas and technology, my request to all of you is that we keep front and center that focus on that positive impact on physicians and patients across Canada. So this is the title of my talk, A Call to Action, Innovation and the Future of Medicine. These are some of the organizations that I've had the privilege of working with, and I like to think of myself at the nexus between medicine, technology and engineering, and entrepreneurship. This is a picture of one of the first models of the printing press, discovered and invented in the 1400s in Europe. And when the printing press was invented, literacy in Europe was about 8%. Knowledge was monopolized by the religious and business elite, and there was no good way to really record information and build on ideas. And I believe that this, in some senses, is where healthcare is today. But the internet and the smartphone and exponential technologies are going to be to healthcare what the printing press was to European society and the world. Because with these new technologies, we are finding that healthcare literacy is exploding, that the patient is becoming newly empowered, and there's much better ways to record to record information about how the patient is doing. And so this is going to have repercussions in terms of how we measure the value of healthcare and how we remunerate for healthcare. And so this is where I think the final strategic objective of the CMA comes in. These technologies are empowering the patient, and I really want to commend all of you at the CMA for saying we're going to be right there. We're going to be part of that conversation. We're going to be part of that shift. We're going to be there with the physicians, the patients of Canada, as these technologies and policies and so on and so forth truly come to create this patient perspective to the work of the CMA and to healthcare in general. I'll make one more kind of historical analogy. This is Martin Luther. He was a priest, a scholar in Europe in the early 1500s, and he put together 95 theses in which he argued with the Catholic Church that indulgences were not appropriate, and he made the case about how he felt religion should be different. And one of the things he did is he nailed these 95 theses up onto the door of some of the churches in his community. And because of the catalytic power of the printing press, his idea spread across all of Europe, ultimately the world, and led to the religious Reformation. So now at the CMA, you guys have a new vision, a new mission. It's about the patient, it's about doctors, but it's also about empowering the patients. So I'm excited to see how the CMA is nailing up this new perspective and focus onto we'll say, the virtual door. And it may be that it's at that time that the smartphone and the internet and exponentials will be that catalyst that allows for this vision of healthcare to spread across all of Canada and be that reformation and be part of creating that reformation in healthcare and changing the way we practice medicine. So as it relates to technological innovation in healthcare, I'm going to start by introducing you guys to exponentials and exponential thinking. So as we think about human history, well, for the last 250 years, it's been the experience of humans has been linear and local. But in the last 100 years, that has changed to become more of an exponential and global world. And to tease out why that's important, or to really bring out the difference between linear and local, let me give you this example. So if I were to take 30 linear paces, I would get from here to the other side of this room. 1, 2, 3. So I would travel 30 meters. But if I were to take 30 exponential paces, and by exponential paces I mean 1, and then 1, 2, and then 4, and 8, and 16, and do that 30 times, I would travel 1 billion meters, or 26 times around the Earth. And as we look at linear versus exponential organizations, we see why this is so critical to understand. Kodak, in 1996, had a market cap of 28 billion and 140,000 employees, and by 2012 it was bankrupt. Instagram, which truly embraced the concept of digital photography and photo sharing and a whole bunch of exponentials, sold in 2012 with 13 employees for $1 billion. You know, there was a time when Blockbuster was doing pretty well. $5 billion of annual revenue in 2008. And 2 years later, it was bankrupt. And Netflix, which had embraced exponential technology and exponential change, went on to effectively rule that segment of the market. Of course, there's the classic example of taxis and Ubers. And so the reason we're seeing these changes is that these exponential organizations are meeting linear organizations, and it's at that point where the exponential technology or business model surpasses the linear model that we have this disruption that occurs. And the question is where is it going to be in healthcare? Does anyone know what this is a screenshot of? This was taken in January or February of this year, and the announcer was talking about why 3 of the largest healthcare insurance companies in the US had had a 5% drop in their stock valuation in the last 24 hours. So you're definitely in the right area. So thank you. It was Amazon was involved, Berkshire Hathaway, and J.P. Morgan, and they had announced that they were going to reimagine how they deliver healthcare to their 1 million employees, and that was enough to shake the market and say, well, maybe they're going to crack the code and come up with a new model. But we have to ask, what is driving this exponential change? Why are we even talking about exponentials? Well, the story starts, to a certain extent, with Gordon Moore, a scientist at Intel in the 1960s. He was tasked with predicting the growth rate of the density of transistors on the integrated circuits of the computers, the computer chips that Intel was making. And he observed that for the last few years, the computer chip density had been doubling every 2 years, and he predicted it would continue on to the future. And that trend, that exponential trend, has continued to this day and has every indication of continuing well into the future. So what does this look like in real, tangible, practical form? Well, the first integrated circuit had 2 transistors, invented in 1958. By 1971, there were 2,300 transistors on the Skookum Intel 4004. And by 2012, 7.1 billion transistors. And then as we compare the NASA Apollo supercomputer to either the iPhone 4 or the Apple Watch, we see that the iPhone 4 or Apple Watch are 120 million times faster than the supercomputer that got the man to the moon. 120 million times. And on top of that, the supercomputer was the size of a car and cost $3.5 million. Now, what if you're into the memory business? Well, back in the 1950s, for a cool 120,000, you could buy 5 megabytes of memory, but let's hope you have a crane to get it around town. And then by 2005, you could get 128 megabytes for $99. You say, well, that's pretty good. But then you just fast forward to today, and it's 128 gigabytes. It's improved 1,000 times in the last few years. And then we look at GPS. You see the same story there. 1981, another $120,000, 53 pounds. You're ready to go. And by 2010, it had dropped to $5 and was the size of could fit on someone's finger. And now it's effectively free. It's built into sensors and cell phones, and it's truly become dematerialized and democratized. What about cameras? Ironically, it was a Kodak scientist that proudly brought this new invention to the board in 1976, the digital camera. Little expensive, resolution needed some work, 0.01 megapixels, 3.75 pounds. But he said, this is important. Kodak, you've got to listen up. But the board, they were the experts in film photography, and so they didn't touch it. They laughed at it. It was a grainy disaster as far as they were concerned. But by 2014, when it comes to resolution, weight, and you see a 1,000x improvement in all of these things for a total of 1 billion times improvement over that period. So this guy used to be pretty cool. But they now fit all into the supercomputer that's in your pocket. And data is following a similar trend. 2003, it's estimated that humanity produced 5 billion gigabytes of data. In 2010, they did the same in 2 days. In 2016, 2 hours. And it's the amount of data that we're producing is growing so quickly that some people say that we have produced more data in the last 48 months than we have in our entire existence as humanity. And Ray Kurzweil, the co-founder of Singularity University and a futurist and someone who has wrote The Singularity is Near and works at Google as the director of the Google Brain Project, has delved into why this exponential growth is happening. And he's talked about and coined the idea of the law of accelerating returns. It's really quite simple, which is once you build the next generation computer, it gets to work with the human on designing the next gen, and then so on and so forth. So we're using better and better technology to design the next generation technology, and that's how we're able to continue to maintain that exponential growth. And a very important observation that he made is that once something becomes digitized, once something becomes information enabled, it jumps on to that exponential growth curve. And so that includes 3D printing, AI, robotics, digital medicine, you name it. Now you might be sitting there and saying, well, the printer doesn't work. You know, you couldn't even get your PowerPoint kick-started properly. You know, in some hospitals, in fact, in the Yukon Hospital, we were using a fax machine to send information between the emergency room and the surgical department. In fact, I was in the emergency room, seeing a patient, and we asked to get some information sent over via fax, and the fax wasn't even working. So I had to run over to the surgical department, get the printout of information, deliver it to the patient, and in some senses, it's as if I would have been better with carrier pigeons, but I digress. Just because there are these frustrations with technology, it doesn't mean that exponentials can't leapfrog. So I think African banking is a beautiful example. At a time in Africa, just a few years ago, their banking and the access to the banking system that many Africans had was negligible or none at all, but they just leapfrogged. I guess this is somewhat relevant to the MD management in a sense. They leapfrogged so many generations of financial innovation and are now the world leaders in terms of mobile banking and mobile exchange of currencies. So we've looked at computing power. It's growing pretty fast. Data is on that exponential trend, and to a certain extent, statistics and the way we parse that information is exponential too. And I mention that because those are the core ingredients of artificial intelligence. And that's why you have all of the core ingredients growing exponentially, and that's why we see 106 startups as of 2017 by CB Insights in the AI healthcare space, focusing on medical imaging, mental health, drug discovery, virtual assistants, wearables, and the list goes on. This is kind of a crazy slide, and it comes from Ray Kurzweil, who you heard about earlier. And he said, well, if I track these exponentials and continue this trend that I've observed and predicted and been talking about for decades now, where does that get us? Well, he said by 2023, he expects that someone could buy a laptop for $1,000 that has the same computing power of a human brain. And then he takes it a little bit farther and he says, well, by the 2030s, I expect that we'll be able to scan the human brain and transfer consciousness into the electronic medium. And then by 2046, he says, well, that's when we reach the singularity, which is where he anticipates that computing power and computing intelligence will surpass the general intelligence of all of humanity. And then we'll see what happens. But that's what Ray Kurzweil predicts and believes will come in our lifetime. So I want all of you to try to put your exponential hats on, and we're going to take a few minutes within our tables to just brainstorm. Think about some of the concepts that I've just shared in your own experience, and try to answer this question prompt. Describe one example of something that you will predict will be entirely different within the next 20 years. It can be healthcare, but if you want to talk about flying cars or teleportation or whatever comes to mind, that's okay too. This is very much an exercise in stretching your imagination and in embracing some of the exponential trends that I just illustrated. So please, dive on in with your colleagues, and we'll check back in a few minutes so that you can share it with all of us. So, which table is going to jump up to kick us off? Here we go. Go ahead.
We were picturing kind of a high-tech healthcare where we could go into the hospital and maybe have something that's similar to the airport. We could step through or be scanned and have diagnosis, that maybe we would have the opportunity to have some choices. So we were picturing kind of a front-end doctor robots, but still having that human interaction at the end.
Thank you.
Our group came up with that in 20 years it will be normal to live to 150 years of age.
Just following up on Stephen's prediction, part of what we talked about was editing of DNA and being able to remove things like cancer and other major diseases that cause people to die today. So they will live for that long, Stephen. I agree with your prediction.
So we were talking similar.
To what Lori was talking about, and wouldn't it be interesting to go through a scan to be able to tell you what's wrong? But the other thing we were looking at is we have a real life situation here where somebody has a broken arm. And so she's been in a cast for 6 weeks. And wouldn't it be interesting just to be able to go in and maybe put some gel to fuse it together and you're on the way?
I hope that gel comes soon.
We have talked about it more at a bit of a societal level, and talked about how much of the technology is going to be more and more inexpensive and therefore more accessible. So the digital or aspiring to see a world where the digital divide is not as great. So to bring more equity to society from that perspective. In terms of the challenges that we talked about, the question of privacy. And sort of all of the ethical components, that's something that we see as something we need to navigate through, as well as the amount of information that needs to be somehow curated and triaged to make sure that we have the right information at the right time in the right places. And on the services side, we talked about services becoming customized, personalized, and delocalized so that you can get access to what you need, where you need, how you need it. And finally, we talked about greater human autonomy, driverless cars, groceries delivered to your door. So all the sort of low-value stuff in your life gets done by machines, so hopefully humanity can focus on the higher order achievements.
Very comprehensive answer.
Okay, so actually we're kind of following on a theme with some of the other groups here. We think that in 20 years, no organs will be unreplaceable, including the brain, whether that's synthetic or organic, either option. We thought that the opportunities and challenges are almost similar in that there's opportunities and challenges both socially, psychologically, financially, and culturally.
All right, one last one, and then I'm going to power on.
We were also struck by the potential of genetic manipulation, and we were talking about the potential to cure rather than treat, and cure in the sense of preventing illness, but also cure in the sense of essentially eliminating a condition or an illness, and the ability to diagnose prior to having any symptoms. And we were looking at the future of healthcare professionals in that world when you're using genetic manipulation as opposed to treating conditions. We were also talking about a future world where we had the ability to essentially exist without relying on extractive resources, so our finite extractive resources, and how that could be a large game changer.
Thank you for sharing, and I think one of the themes there is shifting from sick care to health care, and that came up a few times. There was a collective sigh of disappointment from this table when I said that was the last one, so I feel you guys deserve one quick share here.
Thank you very much, Dr. Edgecombe. I feel very blessed to have this opportunity to speak. So our group talks about, in the future, zero waste. And moving really towards a future where there is potentially very low or negligible emissions, and the opportunity there of the environmental benefits and the high value placed on renewable resources and potential diminishing value of non-renewable resources. And some challenges there is that a lot of the innovation we're seeing is very highly reliant on processes right now that require a lot of emissions. 3D printing, for instance, uses so much plastic. So unique challenges there.
Thank you. Great share. Dr. Wong, who's one of the dual, I think, physician award winners, I saw her in Toronto on Wednesday, and she has biodegradable 3D printing material. So there's even movement in that direction already. So thank you, everyone, for diving in. I really appreciate you guys embracing change and thinking about what the future could look like. And just before powering on to the next part of my talk, I want to make it explicitly clear that I have no actual or potential conflicts of interest in relation to this workshop and presentation. And I also wanted to thank a long list of people who I've consulted as part of preparing this talk and forming my thoughts around the future of healthcare. So I want to talk about the exponential technology trends in medicine today. And there's a long list, but we've covered many of them. 3D printing of organs, surgical robotics, prosthetics, digital health, genomics. I think there were several tables that talked about that. And so we're already, as a group, on the right track, I would suggest. And I want to highlight genomic sequencing. It used to be $1 billion for a genome. Now it's $1,000 or even $100. And it's getting to the point that one day you'll have to sit down to yourself after a long day at work and you'll say, am I going to order pizza or get my genome sequenced? Because it will be the same cost. And it's more than just sequencing our own genome, because once the cost of something, whether it's predictions and diagnostics or genomic sequencing in this context, come down as dramatically as we've seen in genomics, we open up this whole other line of inquiry. The whole gut-brain axis and sequencing and understanding what's happening among the trillions and trillions of bacteria in our cell is made possible because of the dramatic drop in genomic sequencing. And there's some fascinating studies that show that that there are even, you can have some there's predictive value in the microbiome if your goal is to predict whether or not someone is struggling with depression. And so then the question is well, what is that? Teasing out what that connection is and how that works is fascinating and empowered by genomic sequencing. Wearables. The global market for wearables in 2012 was $0.75 billion, and it's been doubling at a rate of about every 2 years, I believe, up to $5.8 billion in 2018. And this is where the empowered patient truly comes in, because we're getting to the point where it's possible to do this continuous monitoring of many of the important vital signs and healthcare signs of people. And this guy took to Twitter to share with the world that he was pretty grateful for his Apple Watch. Because he felt it had saved his life and caught a pulmonary embolism earlier than he would have otherwise. And another example of an exponential trend in medicine is EMRs. They've gone from, across all of Canada, among primary care physicians, the rate has gone from 16% adoption to 85% in the last 15 years or so. And that, there's lots of growing pains and groans associated with EMRs, and doctors are concerned about the time they spend on the screen versus the patient. But the point remains, this is part of the movement towards this information-enabled era of medicine. This is a slide from Ontario MD where they talk about kind of the ideal EMR as it integrates information from the hospitals, the specialists, the labs, the pharmacists, walk-in clinics, family practitioners, and I took the liberty of adding patient-generated data should be feeding into the EMR. And the arrow goes in both directions. I believe that in the not-so-distant future, it will become commonplace for patients to have access to their full medical history. There's some very interesting studies that have been done around this concept. And there was one study with 100 doctors and thousands of patients. And at the end of the one-year study, 97% of patients and caregivers said it was helpful. Most of the physicians said it didn't increase their workload, which was one of their main concerns. And interestingly, all of the doctors continued to keep it on after the end of the study, this kind of open notes access. And so that's just another way that I think healthcare will change. But let's get back to that Uber example. It delivers a better and less expensive service, empowers the consumer, smashed regulatory protection of the taxi industry. It made licensing and insuring as we know it of that profession largely obsolete, and it's growing exponentially, and it will soon disrupt itself. And it's going to disrupt itself because Uber is investing a lot in self-driving cars. And so they're going to disrupt their existing business model with a new one. It's not to say that Uber, by disrupting itself, will cease to exist. It's kind of embracing the mantra of disrupt or be disrupted. They're prepared to invest in the next generation of technology and be part of the disruption. And if we look at the price of taxi medallions in New York over the last 2 decades or so, we see that it was right up to close to $1 million in 2014, and then Uber showed up. And so the kind of call to action that I bring to physicians and the CMA and to everyone in the healthcare profession is let's not get distracted fighting for medallions. Because that's what happened to a large extent in the taxi industry. They were busy fighting for this finite pie of medallions and totally neglected and missed this exponential innovation trend in the Uber, with what Uber represents. And so in healthcare, we really need to take that message and embrace it and work together in the healthcare world to say, how do we expand what we can do? How can we be exponential? How can we disrupt ourselves? And so I'm going to give you now some case studies of exponential change in medicine. I talked about some trends, but now we're going to dive into some specific examples. And for the skeptics in the crowd, I have this video. We just need to have some audio. I'm going to see if we can hit the audio for this video. All right, I'm going to, it's pretty easy to narrate. He says, Emma. He goes, Emma. Emma, come on. Emma. Emma. Emma? So, in this next part, we're going to look at company case studies, digital diagnosis and treatment, as well as some augmented reality examples in medicine. So to start with the case studies, we've got some Canadian examples in Seamless MD and Cloud DX, as well as we'll look at Apple Health for an international perspective. Seamless MD came about through a hackathon session, which included Josh Liu, who was a U of T medical student at the time, and they had the simple idea that they could embrace cell phone technology and tablets and just create an integrated set of information and monitoring capabilities for patients as they prepared, went through, and came out of surgery. And it's got basic information like, what should you do before surgery? What are the things you should do in terms of your diet, and when do you have to start fasting, and what are the exercises that you should be doing with rehab, and ways to track a variety of outcomes as patients come out of the surgery. What is their flexibility? What is their pain? And answer basic questions like, should you be concerned about blood in the urine? They've had some really impressive results in a study at Sinai Health System. They showed a 30-day readmission rate decrease of 67%. For thoracic surgery, a 46% decrease in emergency room visits. And I think this is where we start to see, this is where exponentials start to relate to the hallway medicine that we all fight against and rail against and say is a problem. So it's not necessarily more beds in the hospital, it's maybe a smarter application of these technologies that can help us solve the hallway medicine, for lack of a better word, epidemic that exists across Canada. Seamless MD has had a lot of success through a variety of pilots across the Ontario and Quebec landscape. But I also want to talk about Cloud DX. They are a company which has provided these connected health kits which provide remote patient monitoring, blood pressure, weight, temperature, blood saturation, and glucose, and also provide a portal for telemedicine and EMR integration. And they have shown that when they give this to patients, that there's an improved adherence rate in terms of their treatment plan. And they're currently undertaking a study to look at whether or not this reduces readmission rates among COPD patients in an Ontario hospital. And they've also developed something called the Vitality. And I'm going to ask Deborah to stand up and be a little bit of our model here. She is wearing it right now, so you want to pop it into your ear, and we can take a quick look to see what this is able to do. So in theory, what it does is it tracks a combination of blood pressure, oxygen saturation, temperature, heart rate, and EKG, and it tracks all of this information in real time. And so right now, CloudDX has rolled this out in hospitals, and they're comparing it in post-surgical patients to see how it matches to the gold standards of the more expensive and bigger and heavier measurement equipment that they use in hospital for post-surgery patients. I should say this was a demo, so this is not actually Deborah's vitals. But thank you, Deborah, for volunteering to show it off. So technology adoption is challenging, and it's important for the CMA to get kind of a frontline perspective of what some of the challenges are that Josh Liu, the CEO of Seamless MD, and Rob Call at CloudDX have had to overcome. And so I asked them these three questions, and when it came to the big, bold vision for Seamless MD, Josh talked about being being able to provide continuous care being able to provide the care that patients need through the entire continuum from birth until death. That's what Seamless MD is trying to set out to do. In terms of barriers to adoption, he said that they've had way more success in the accountable care organizations in the US, where they're incented to look at how to drive down costs associated with patient admissions for surgery in a way that is not the case in Canada. And he also noted that the procurement system in Canada makes it very challenging for innovative solutions to get into the system. And his message to the CMA was be needs-focused and try to use technology to address those needs. And he's done it in the context of healthcare, and I'm sure you guys could do it in the context of the work of the CMA. With regards to Rob at CloudDX, he talked about their big, bold vision of being the trusted partner between the patient and physicians of Canada. He said that he identified two barriers of adoption. One was the issue of how can the doctors trust new innovative ideas. They have so much on their plate, it's hard for them to make the time to actually determine whether or not they can trust new technology. And he also said that doctors are scared of the data. So what is a doctor supposed to do when CloudDX sends an alert to the EMR that this patient is potentially at risk of a COPD exacerbation? There's the current institutional setup of the healthcare system doesn't really even allow for them to react to that. So just managing the data and limiting the number of alarms, things like that, is a challenge with regards to adoption. And his message to the CMA is there's so much potential in EMRs in terms of information-enabled technology, but their interoperability and the ability to integrate into them in terms of sending patient-generated data into them is still very poor. And so there's opportunity from his perspective in terms of lobbying and advocacy for legislation around that, forcing that interoperability. Apple Healthcare deserves our attention because it's one of the top 10 tech companies in the US, and a report showed that the top 10 top 10 tech companies over the last 5 years have increased their investment in new acquisitions in the healthcare space from $300 million per year to $3 billion per year. And so they're getting into the healthcare space in a big way. Apple is looking at better ways to integrate, the hospital EMRs onto the doctor's smartphone, personal medicine record storage on iPhone. So they just rolled out a 43 medical institution program where patients can go with their iPhone and get all of the medical information onto their iPhone from the hospital that they're visiting, and then they can take that with them to wherever else they go and access it on their cell phone. And Apple is also getting into the chronic disease management space, and that's true of a lot of these healthcare innovators, as they believe that they can drive down the costs of management of chronic disease, subacute, and trying to prevent those trips to the emergency room. And Apple Healthcare is certainly looking at that trend. The cardiogram study that Apple Healthcare ran was very interesting because in just a few months ago, sorry about that, they announced that using the data from 14,000 people that had participated in this study, they had shown that using machine learning and AI and the data that was generated from the Apple Watch measuring simply the heart rate of the patients could detect diabetes they could use that to detect diabetes with 85% accuracy. That's kind of a mind shift, because here we would have thought that diabetes is something about sugar in the blood, and yet through continuous monitoring it may be possible to diagnose diabetes just with the heart rate alone. This is a quote from a director of the My Heart study that used the Apple Health Kit as a research platform, and he said that to get 10,000 participants enrolled in a medical study would normally take a year in 50 medical centers around the country. And that's the power of the phone, because when he launched the My Heart studies, they had 10,000 people sign up in one day. And so you can see how this platform is changing how we can collect health outcomes and do research in the healthcare space. So let's talk about diagnostics, digital diagnostics and treatments. Well, Jeff Elton is the author of Healthcare Disrupted, and I understand from Dr. Brody that some of you have been reading it. This is a book that Dr. Brody encouraged me to read, and Jeff Elton, in personal correspondence with me, talked about what his next book is going to be about. And he said that ambient data sources may already enable a level of precision and insight into health status beyond what can be measured in a typical physician office visit or ambulatory setting today. So stay tuned, and you'll see a whole book from Jeff Elton about this very concept. And the reason he talks about that is because let's look at the digital doctor's bag of today, really. You can have an ophthalmoscope, an otoscope, or even an EKG in just that attaches directly to your iPhone. So if anyone wants to check out your heart later, you can just come and check it out on my phone. And Dr. Topol, who is the author of The Patient Will See You Now, said that he realized that healthcare had changed back in I think it was 2016. He got an email from one of his patients said, "Hey doc, I'm in atrial fibrillation, see my EKG attached, what do I do?" And the reason he was able to say that was because AliveCare has used machine learning algorithms to be able to detect whether or not someone has AFib based on the EKG readings from their phone. And I took my readings a little while ago, and fortunately AliveCare came back and reported that I had a regular rhythm. And then there's dermatology. Right now you can take a picture of a skin lesion that's concerning you, upload it to the cloud, and for $29 have a dermatologist look at it within 48 hours and get back to you about what it is. But so those are all kind of devices and services, human-enabled services, but this is a really important chart that I want you guys to understand. So object recognition and images is changing, and it's really reached a tipping point. So in 2010, a group of computer scientists put together a large-scale visual recognition database. And they had put together 3 million photos labeled across with thousands and thousands of different objects within those 3 million photos. Cats, dogs, 1955 Chevrolet, cloud, whatever. And they labeled them, and they said to the computer scientists, the computer science world, is use machine learning, AI, whatever you want, to learn how to detect these objects, and then we'll see how accurate you are. And in the first year, it was really laughable, 70% accuracy. You know, the computer was calling a monkey a cat, a dog a cloud, and it was kind of cute. But within 5 years' time, using this deep convolutional neural network technology and machine learning, you can see that the abilities of the computers in 2015 surpassed that of humans in terms of 95% object accuracy recognition. And by 2017, they said this is the last year because we've done it. There's not much more room for improvement. And this is important because object recognition naturally ties into many aspects of medicine. So this was released on April 11th with FDA approval, this autonomous detection of diabetic retinopathy. This device is about the size of someone's head. It's explicitly marketed to non-ophthalmological, non-medical professionals, where it's possible for someone to just come and put their head into this device. It'll screen their eyes and come back with a diagnosis of diabetic retinopathy if it's there. This is very important because diabetic retinopathy is one of the most common causes of blindness across the world. It's caused by diabetes and leads to blindness. And so this is massively scaling the impact and massively improving healthcare around the world as this gets rolled out, because we no longer need an ophthalmologist to make the relatively simple diagnosis of diabetic retinopathy. Then there's dermatology. In 2017, computer scientists at Stanford came out and said that using 120,000 labeled images of skin cancer, they were able to train their machine learning algorithms to detect the most common kind of skin cancer and most malignant kind of skin cancer as accurately as board-certified dermatologists. In pathology, there's a company that just raised $25 million and are trying to do the same in pathology in terms of using labeled image slides to improve their ability to do diagnostic work and image recognition. And then in radiology, Arteris is a startup company based out of Silicon Valley. They're using the best of machine learning and computer vision to detect and be able to segment heart chambers within CT scans. This is something that used to be reserved for junior radiological residents who had to painstakingly go through the entire volume and segment it out for the purpose of looking at ejection fraction and measuring the health of the heart. Now Arteris can do that in the cloud for you. And where Arteris sees their first really exciting application is right here. They are quite good at being able to detect lung nodules in both X-ray and CT scans that could be a sign of lung cancer. And just in 2017, the European position statement on lung cancer said European countries need to set a timeline for implementing low-dose CT lung cancer screening. So now you have potentially millions and millions of people who are getting CT scans and who need their scans interpreted, and there's no way that the radiological community can keep up. So Arteris says, let's step in and we'll take care of that. We're good at detecting these little lung nodules in CT scans, and on top of that, we're even better than a human at tracking how those lung nodules change year to year, because they can match the CT scan from the previous year to this year and see how each of those individual lung nodules are changing. And then another group of scientists came out and they said that using a full-body CT scan, they could predict whether or not someone was going to die within the next 5 years with a 69% accuracy. And so that's kind of the diagnostic space in a more technical manner. But what about the history? The thing that when you go to the doctor, you sit down with the doctor and go through the history of whatever it is that you're presenting illness. You share with them what is on your mind. Well, K-Health is an example of a startup company based out of Israel, and they're trying to answer this question with their app. They want to allow someone who has their app to say, what do I have? What else could it be? What are all the different ways to treat it? And to be able to answer that question, they took 25 years of medical data, 2.2 million medical records from 2.2 million patients, 268 million doctor-patient visits, 1.6 billion blood marker tests, and 80 million med prescriptions. All of that they parsed through their computer vision their machine learning algorithms, and they built an ontology, which is effectively a way for the computers to understand all of that data. And with that, they help to match the symptoms that you may have, that you're entering into the app on the phone, match that to the patients that they already have and the records of patients they have in that data set. And so this is what it looks like if you're using the app. Let's say you have chest pain. When did it start? Do you have a cough? Where is the pain? And then it looks through that 2.2 million patient data set and tries to find matches, and then says, well, there's a 59% chance that it's some musculoskeletal chest pain, and it goes down the list for other potential options in terms of what that could be. And then it says, well, if you have musculoskeletal chest pain, this is how people treated it. 7% took tramadol. And you can even follow it all the way through to see how people with tramadol did, what their prognosis was, and so on and so forth. This is what the app generates in terms of the history, and this is the chest pain report. And K-Health is interested in partnering with health institutions around the world. And I spoke with our CEO, and he said, I'd love to bring this to Canada. It's not the technology that's holding us back. It's that do we have some kind of the political capital to come in and partner in a serious way with a health system? And so the question is are there primary physicians in Canada that want to adopt this? Is this going to help them do their work more quickly? And how do we have that conversation in a respectful way to make sure that they aren't feeling threatened by it, but that they realize that this is a way to scale their impact? And, you know, this is not perfect. It doesn't come up with the right diagnosis a lot of the time. It only has 160 conditions right now in the database. But if we think back to that image recognition example where 5 or 6 years ago it was calling a cat a dog and a cloud a monkey, and it was only at 70% accuracy, but remember how quickly that surpassed humans' abilities to do object image recognition, you start to imagine that this could be the same case in some of the kind of simple medical conditions that someone would be using K-Health for. And then we talk about treatment. So where does that land? Well, this is an interesting study published in 2018, focuses on diabetes, and the results were incredible. 60% of people reversed their diabetes, 94% of patients reduced or eliminated insulin, and there's just some incredible results. So you might be saying, well, what was that miracle drug? You know, how do I get some of that? But it turns out that all that they did is they brought together exponential technologies and offered a combination of physician supervision, continuous monitoring of a whole bunch of biomarkers, on-demand resources. And what I thought was pretty cool is this private Vertec community. They connected patients with each other so that patients with diabetes could share the journey that they were on and share tips and tricks that helped them with that chronic disease. VR treatment. This group came out and showed that giving a patient a treatment in virtual reality showed a 60% reduction in the pain they reported and associated with their chronic pain. And so it's really a whole new avenue of treatment, whether it's for PTSD, whether it's for anxiety, or whether next time there's a patient who's recovering from surgery and you want to send them off to Hawaii, you now have the opportunity to do that. And where exponentials get really interesting is this is where virtual reality was in 2012. This is Palmer Luckey, 20 years old, little tinkerer, works in the garage, and he put out a crowdfunding campaign. And he said to the world, look, I want to build a better virtual reality goggle, and he raised several $1 million from a bunch of gamers that said, that sounds cool. I want to have a virtual reality goggle, and he had the innovation, and he used a variety of tools to come up with a better virtual reality goggle. And Facebook went on to buy his company for $2 billion a few years ago and are continuing to work on it. And we see how now it's starting to be applied in medicine. And then there's this, you know, this is all what we call the digiceutical space, the treatment, treatments with digital tech. And we can see over the last 10 years, the number of trials in this space has gone from effectively 0 in the US to 150 in the first 8 months of 2017. And this is from The Economist. So lastly, there's augmented reality in medicine. This is just an interesting example of a new way of thinking about technology and how it could change how we practice the workflow of seeing patients, or could change surgery, or it could even change education. So this is an application of Google Glass. There's a company called Augmetics, which is developing augmented reality for the purpose of, so that a doctor can see a patient but also look through some of the relevant medical history at the same time. So this is what the doctor would see in terms of, in the top left of their vision. They'd have that information while dealing with the patient directly. This is one of my colleagues at Imperial College London who did this work, and he used these HoloLens glasses, which you guys can have a chance to try out at lunch. And when the surgeon puts these on, instead of seeing just the leg, they actually see the detailed vasculature of the anatomy within the patient. And that's important because in this free flap surgery, the surgeon will actually take out some of the muscle from the leg, but it's important that they maintain the vascular supply of the muscle. So it's important for them to be able to know where the blood vessels are before they start their surgery. And then neuroanatomy is something that's close to my heart because I was a neuroanatomy TA and spent a lot of time trying to explain to students, okay, this is this is where this nuclei is, this is where this part of the brain is, but it was hard to get a three-dimensional sense of what the brain actually looked like. And this is the neuroanatomy HoloBrain app that has been developed, and that's what you'll get to try out at lunch. So you'll actually get to put on these glasses, and there'll be a 5-foot brain just floating there in front of you. You can look at it and get a new understanding of what the brain actually looks like. So we've seen company case studies, we've seen digital diagnostics and treatments and augmented reality in medicine. And so we get to give a check mark for technological innovation in healthcare. And I want you to keep in mind that original analogy, the printing press. Hopefully you're starting to see this new vision for healthcare, which is enabled by exponential tech and the smartphone and the internet, which is really empowering the patient. Some of the crazy ideas that came out through this, some of the prospective competitors said they're going to use blood to detect a disease of the brain. Another scientist said they think they can train dogs to detect Alzheimer's and then figure out what the dogs are doing to detect the disease. And in terms of the treatment, I think embracing these exponential technologies of genomics, microbiome, proteomics, this continuous health monitoring, personalized neurocognitive tests on someone's smartphone, those are going to be the breakthrough technologies that allow scientists to get this exquisite snapshot of someone's brain health and then start to develop personalized interventions, whether it's an off-label drug that used to be used for liver transplants, or it could even be meditation. The combination of all these will likely slow the progression of the disease and may ultimately contribute to our understanding to end the disease. Our moonshot is something along the lines of a vaccine for Alzheimer's. This is a picture of Jonathan Salt giving the polio vaccine to a little boy, and the polio vaccine was so successful and polio effectively eradicated from this world that there are people today that don't even know what polio is. And it's our dream that in the not-so-distant future that people say, Alzheimer's what? What is that? That it's truly eliminated from the planet. So we've looked at technological innovation, crowdsourcing as a way to generate kind of a new model for innovation. And with regards to crowdsourcing, my challenge to all of you is think about how you can use it in your work. So maybe you're passionate about a big cause and you want to work towards creating a global crowdsourcing competition, but you can also get your feet wet by going out to the crowd to get help with your next presentation, your next marketing strategy, your next prototype for whatever you're working on. There are platforms like freelancer.com, 99 Designs, Kaggle, and HeroX that allow for you to connect directly to the crowd. Of course, the crowd can also go the other way and fund big ideas. So Kickstarter is a platform that has supported and successfully funded 40,000 novel ideas and raised over $3 billion. And the most successful Kickstarter crowdfunding campaign raised $7 million in the first day because people were so excited about the vision and the product that this inventor was proposing to develop and deliver if people put up the initial money to pay for the product development. And with regards to mindset, I want to talk to you about the ABCs, and it's actually ABCs, DEFs, of developing an innovation mindset. And for this, I just decided to share some stories with you. I've had the privilege to get to know some people that I really respect and that are really at the edge of innovative thinking, and they've shared some pearls of wisdom, strategies that they use in their lives to be successful innovators, and I believe that you can use them yourself as well. So in this picture is Lisa Genova. Some of you guys might know Lisa Genova because she was the author of Still Alice, which is a book about Alzheimer's disease, a feature-length Hollywood film, and she's given a TED Talk about Alzheimer's that has had over 2 million views. And she was one of the senior advisors to our Alzheimer's X Prize team. Now, she was originally trained as a Harvard neuroscientist, and she said that as a scientist, she was exquisitely talented at dissecting an argument and then saying why it wouldn't work. But she said as she was making this transition to this this new career where she was trying to be an author and really embrace creativity and come up with, a compelling way to talk about this horrible disease of Alzheimer's that engages the public and helps them learn about it. She adopted the principle of and yes conversations. So instead of being the scientist that says, this is why it won't work, she said she really just worked on saying and yes, and then building on whatever idea or whatever idea was in the conversation at the time. And she said that led to a lot of big breakthroughs for her in terms of how she thought about writing her book and being creative. This is Evan from Google X and the Google Moonshot Factory, and he came to speak to my class at Singularity University in 2016. And one of the projects he talked about was the Google Loon project. It's really a crazy idea because Google said, well, how do we get internet to everyone in the world? And they said, well, we'll just use hot air balloons with receiving, transmitting stations, and we're going to blanket an entire country, or ideally the world, just by using these balloons and having them go up and down so that they can catch the air currents and maintain this continuous distribution of transmitting internet stations. And he said that this idea for this Google Loon project, I mean, these are massive balloons, came out of a bad idea brainstorming at the Moonshot Factory at Google X. And the concept of a bad idea brainstorming is simply one where there's no bad idea. In fact, you're trying to embrace bad ideas. If someone comes up in your brainstorming session that seems practical and it's probably going to work, he said that at Google X they go back and they say, come on, buddy, let's get a bit more crazy. We want to stretch our thinking. Let's stretch our thinking. Now, eventually, you have to bring it back down to something reasonable, but he said bad idea brainstorming, that's where the Google Loon project originally came from. And Astro Teller's the director of X and the Moonshot Factory, and he talks about how to get people thinking creatively, he'll go in and he'll tell his team, I want a 10x improvement, not a 10% improvement, because once you say that, you have to throw out everything you know. And you can't get a 10x improvement out of an internal combustion engine. And to a certain extent, Elon Musk threw out everything he knew about that and said, we're going to focus on electrical cars and electrical transportation. In my case, this is a little story from my own research, which is when I was working as a PhD student, we looked at the multi-billion-dollar cell phone industry, and we recognized that they were investing a lot of money into this towards the goal of miniaturizing a projector and making a projector so small that it could fit into a cell phone and be as ubiquitous as the cameras that are in our cell phones today. So we said, well, why don't we just take that apart and reconfigure it for the purpose of minimally invasive surgery, and then we could have this projector that we could use with surgical robotics and minimally invasive surgery that we could use to map out the three-dimensional surface and then ultimately project information onto whatever surgical surface the surgeon was looking at so that they could get information about the underlying tumor below or the blood vessels that they needed to know about as part of planning their surgery. And so there I want to point out that was positioning the project at the convergence of exponential technologies. We looked outside of the medical field to the smartphone digital projection world and identified that could potentially converge with surgical robotics and minimally invasive surgery, and ultimately developed what we call the Pico Lantern, which we patented and licensed to a Canadian company called NDI. And then this is a little story from Peter Diamandis. He's the co-founder of X Prize and Singularity University and 19 other different organizations, for-profit and non-profit. And I have not been in a conversation or a presentation with him where he doesn't say, figure out what you would die for and live for it. He prizes passion and finding what you really care about. And I think that if, you kind of have an unfair advantage at the CMA because you have such an incredible mission, empowering and caring for patients. That's great. And so if that resonates with you, and you know that you're part of that mission, then you're right on track in terms of finding what you really care about and executing on it. He also talks about experts will tell you what can't be done. And I have more of an appreciation for that. having been through the X Prize ideation process for Alzheimer's, there were lots of people that said things can't be done, and Einstein famously said in 1932 that nuclear energy would never be attainable. And 15 years later, that was proven not to be the case. So I think that's important to keep in mind. Respect your experts, but also understand that they've been doing something for many years and they know what the constraints are. Dean Kamen, this engineer has over 1,000 patents. He's the inventor of the Segway, of the most successful at-home renal dialysis unit, and much else. And he really embraces failure as okay. In fact, he said he's at the point in his career where he doesn't take on a project if he knows what the solution is going to be, because he's got his best learning out of failure. In fact, he doesn't even really see failure as failure. He sees it just as another learning experience. He recently got a grant from the Department of Defense to develop a regenerative medicine institute. He's an incredible engineer, doesn't know much about healthcare, so he proudly showed up at the White House where he received $85 million, and he said, "This is all very nice. I'm so glad you guys are giving me the money. There's a slight catch. I don't know anything about regenerative medicine, but I'm a good engineer, and I think that we've got the right science out there, and I'm confident that over the next 5 years we're going to figure these things out, and we're going to create regenerative medicine in a whole new way." And regenerative medicine is, to the point of that other table, mostly focused on creating prosthetics and artificial organs. So those are the ABCs of DEFs of innovation that I hope you will bring into your everyday work as well, because innovation can come from moonshots, but it can also come in the day-to-day in terms of helping the whole organization to embrace that kind of thinking, embracing that you can take risks and come back and have a failure, but that's okay, because that was the richest learning experience you've had over the past year. So we've seen tech innovation, we've seen new models for innovation, we've seen a mindset around innovation, and I hope all of that provides the ingredients you need to kind of get that vision for where the world of healthcare is going, see where CMA is going, and how CMA fits into all of that, and also gives you a vision for what you want to be doing with your career and improving the fulfillment that you get in your work, and thinking about new ways of achieving your goals. So thank you very much. It has been my great honor to be here, and I look forward to working with many of you in the workshops later on today.
Thanks, Philip. So I don't know about you, but I'm scared. There's so much stuff happening out there, and unless you have a line of sight in some of these things, you think, oh my God, like when did that happen, right? You kind of turn the corner and all this stuff is right there, and it's live, and it's today. I was just saying to Joseph that I think one of the takeaways from me, I'll just make it now, is remember last year I asked everybody what their favorite Christmas movie was? What I'm going to challenge people today to think about when they leave here is to send me a list of their favorite movies of the past that are now coming true. And there are so many. Like we were just saying, there's some disturbing ones like Mechanica. There's Gattaca. There's so many movies out there that were developed over the last 2 decades, and you think, oh my goodness, like this is actual reality today. So think about that, and email me your lists in terms of those movies, and then we'll share them. We'll do the collective like we did at Christmas time. For me, so I'm just going to throw a couple of challenges out there. We've got a pretty exciting day ahead, and I'm going to ask Christine to come up afterwards and just describe what's happening, I think, or Janice, or somebody will pop up. So for me, one of the things that keep resonating with me, and I wrote some of these things down. So where I think we have some gaps, I've talked to SMT about this, is we don't really have a lot of thinking or people, reaching out to people to talk about technology and the impact it has from a policy or advocacy perspective from the CMA's view. We used to have a position at the CMA called the Chief Technology Officer, but it wasn't what you thought. It wasn't like the tech person, in the organization. Bill Pascal was that person, some of you may have remembered him. But we haven't had that role in a while. And so I've been talking to SMT, and Owen's been bugging me about it to say, look, we have a huge gap, just based on this, the stuff that Philip's talking about today. And part of that as well, where I think we have a gap, is around big data. And I got an interview yesterday by Ipsos, because they're helping CMPA, which is another organization that we're all familiar with. And they're trying to figure out big data, how they use big data, to help improve the safety of patients and help physicians in the health system that they're working in. And this is an area that I believe is a big gap for us, because again, we don't spend much time in that area, and we need to think about the future implications, as was articulated by Philip. The other area that really excites me, that I'd like to explore more, is the whole concept of the crowdsourcing. But not so much for money. I mean, one of the concepts that I've had, and I've talked to people about this, is that we lowered our membership dues to $195. I've had a lot of physicians talk to me and say, well, why not just make it free? You're now a billionaire, so why are you even charging us? And my future vision for what we do with membership dues is actually say to members, we want to apply your $195 to the priorities that you think that the CMA should focus on. So the issues and causes that matter, where would you like your $195 to go? Is it Indigenous health? Is it seniors care? Where would you like us to apply it? I think we have the opportunity to do that. I'd like to see us do that sooner than later. The other area about crowdsourcing, though, is the platforms that are available for crowdsourcing. How can we take that platform and turn it around for engagement? So how do we use crowdsourcing to help us with engagement with our members and with patients? That's a challenge that I'm giving to you to figure, how can we make that happen? Because it's out there, it's being used in so many different ways, but how do we apply it to our world as an association based on our mission and vision? I love the idea of bad idea brainstorming. I think the whole concept of what just transpired last week, some people said to me, that's a bad idea that we look at something, right? Very bad idea. I don't think so. I think it's going to set everybody up, for a really supportive future. And then I love the concept, and I've been hearing this more and more as I hang out with Philip and Dr. Brody and others, and even Terry Albert. I mean, Terry Albert was, the big supporter of bold and 10 times, and challenging us to say, you have to think differently if you think 10 times. And so Philip just reiterated that today, and it's good to see that, that's kind of the mindset and the mind space that, particularly with the gift that we've been given, $3 billion, we have to think bigger, much bigger. We can't think the way that we have been thinking in the past. It's just not acceptable. And you know what? I love the idea, I'm going to give this to a lot of friends and family, figure out what you would die for and live it. You know what? So many different personal and professional passions in life. And I don't know, I'm a big fan of cars, as many of you know. I love Jerry Seinfeld. He's got this great show, Coffee and Cars. He takes out these comedians in these cars. And there's one episode where he takes out Gary Shanley, God rest his soul, because he did pass away. But in this episode, Gary Shanley, he does nothing but complain. And every second sentence, he's like, yeah, well, I had a sore back this morning where I woke up. So it's slowing me down today, Jerry. And Jerry's like, oh my God. He's like, yeah, I was going to go to that show the other night, but, I just wasn't feeling good. I was having a hard time breathing. And so Jerry has this ding meter. When he's interviewing him, he dings, he goes ding every time that he complains about something. And so for me, this, figure out what you would die for and live it, it's, think about the positive in terms of, if you're not working on stuff that you think is going to support the vision and mission, then change it. Don't complain about your environment and where you're at. And, think about what people have to do each and every day to get up to go to work. When you think about people with, disabilities or challenges, how easy is it for us to get up, put your shoes on, get in the shower? I mean, there's so many things that you can think of in terms of being thankful for. So I love that. And when I meet Peter Diamandis again, I'm going to say, look, I'm going to write that on my walls. And you know what? And this is one thing that we can all live by. Experts will tell you what can't be done. This is such a big thing, particularly with, I'll pick on physicians. So, physicians are trained to look out for the negatives. Like, that's what they do. They're trained to be critical, right? And so it's not surprising when they're critical of things that we bring up or that we're doing, because they're trained to do that. And so I think that that's something that we need to consider. And I've said this before, status quo is not an option, and failure is okay. I think, you've all learned enough over the last couple of years that it's okay if we fail. We'll try stuff, if it doesn't work, we'll readjust. And I think that we're adopting, that culture, and we're moving in that direction. I think we still need to get the board of directors there, because again, they're trained not to fail, right? Think about it. It's actually not a good mantra for doctors. Failure is not okay. It goes against every grain in terms of how they're trained and the world that they live in. And so, again, you have to think about the dichotomy of the two mindsets there. So I just wanted to say, Phil, thanks again. I've seen this presentation a few times. Every time I see it, I take different notes because I think it's just so amazing to see what's going on, that there are people that work on this full-time, all the time, in terms of preparing a better future for all of us. And I think we can be a part of that. And we have a huge opportunity to be a part of that. We just have to figure out what that is and what our role is. So thanks, Philip. Looking forward to seeing you again. I keep bumping into you. I keep selling him. I should get an agent fee. I've introduced him to 3 or 4 organizations where he's done the same presentation. And the feedback I keep getting is, wow, I'm so happy that you introduced us to Philip. So thank you very much.